Hello and good afternoon, everyone. It's an exciting time in the XR industry. And as Unity creators building content for XR, you're right in the middle of it. We're so excited to have you here for this session. Today, we're going to talk about how you can bring existing XR projects to Android XR. What carries over, what things to consider, and how to take advantage of Android XR's unique capabilities. But you're not just going to hear from me this afternoon. So here's a few introductions. I'm Anthony Bowker. I'm the Director of Engineering for the XR platform teams at Unity. The teams that work with me build all of those many packages that you may be familiar with inside of Unity. And I'm joined today by Luke Hopkins from Google. He's on the Android XR team, and he's going to have the demo for you. And after that, we have Petter Nygren from Resolution Games, who will talk about bringing Demeo to Android XR. So here's what we're going to cover today. First, we'll talk about OpenXR portability and how the work you've already done in Unity carries over easily to Android XR with very few changes, thanks to the XR foundations already in place. Then Luke will talk through the actual porting workflow, step by step, so you can see what it looks like to bring a project to Android XR. After that, we'll talk about performance tuning, things like Vulkan upgrades, eye-tracked foveated rendering, and even addressing generative AI and adding that to your apps. And finally, we'll wrap with a studio who's already shipped on Android XR, Resolution Games, and hear what it took for them to bring Demeo to the platform. But before we dive into the technical side, let's talk about why Android XR. First, reach. If you've already built on top of OpenXR, most of your work carries across. You can bring your project to new devices and new audiences without having to rebuild from scratch. Second, you can use familiar tools. Using the same Unity workflows, the same cross-platform APIs to bring your app to Android XR. It's going to just feel like a continuation of your work. Third, the ecosystem. Android XR isn't just one headset. It's a growing platform that's expanding from headsets to next-generation glasses. So the work you do now will set you up for everything that comes next. And finally, timing. XR and AI are moving fast. And together they're unlocking new experiences that we haven't been able to build before. So it's a really cool time to build in this space. I'm glad you're here. So with that in mind, let's take a look at how Unity's ecosystem makes this possible. So let's talk about some of those fundamental packages that we have in Unity for XR. The stuff that will travel with you, no matter which OpenXR runtime you're targeting. These are the foundational building blocks that most XR projects use. First, there's the OpenXR plugin. This lets your project talk to OpenXR runtimes, like Android XR. It's that core compatibility layer. On top of that is AR Foundation. We'll talk a little bit more about this later. This was originally developed for AR, augmented reality, on phones, but has been extended to support headsets as well. And it abstracts the things like plane detection, anchors, occlusion, and works across OpenXR and non-OpenXR platforms. Third, we have XR Hands. This is our cross-platform hand tracking API. Same story here. Works on both OpenXR and non-OpenXR platforms. There are other parts of the XR stack here. Things like XR Interaction Toolkit and composition layers. They're also across platform. But the point here is if you use the high-level Unity packages, you'll be set for cross-platform development from the start. Here we have things in a bit more detail. At the top, we have your code, your scripts that you've made, your gameplay logic, your UI, everything you've built for your experience. And that connects down into the Unity XR layer. And these are the packages whose APIs you will use. XR Interaction Toolkit, AR Foundation, XR Hands, and composition layers. These are the feature packages that give you that consistency across platforms and stop you from needing to write device-specific code. And under that is where we have then all the layers that make that possible. Next, XR SDK, which integrates those packages into the Unity runtime and then to the actual platform runtimes underneath. And that's where you see the different provider plugins. And as you see, there's quite a few platforms there. The two on the left, Android XR and MetaQuest, are both OpenXR runtimes, but we also then have support for others, PlayStation VR 2, Apple Vision OS, as well as AR Core and AR Kit for doing AR on phones as well. This is what makes porting easy. So when you look at our packages, there's a lot of them, but they help you get what you need. Now that we've looked at the overall tech stack, let's zoom in a bit on OpenXR, how it works in Unity today, and what that means for bringing your project across to Android XR. So OpenXR, what is that? That's this open standard that's an industry standard that defines how applications can talk to XR hardware. And it gives that shared foundation for building features the same way across multiple runtimes. And it's one of the main ways that Unity connects to those runtimes today, especially for head-mounted displays. So it's a detail that sits between Unity and those devices, translating your apps into what those devices expect. So if you're building for those OpenXR platforms, you'll find that things translate really easily across them. Although each runtime can sometimes have its quirks. Unity has been part of the OpenXR standards body right from the beginning. We're a founding member of the working group, and today we ship multiple OpenXR packages in production, like Android XR, and there's a lot more coming. We've been working with the group on things like spatial entities, which is the more modern, scalable interface for AR features in the future, along with continued standardization efforts, all of which point to a very robust and scalable future for OpenXR. So let's take a look at what's currently supported for Android XR across these packages. So these are the things I've been talking about: the OpenXR plugin, the OpenXR Android XR specific plugin, and on the right we have XR Hands. This particular one in the middle builds on the OpenXR pieces, the standard pieces like controller input, eye tracking, and foveated rendering, refresh rate, and space warp, with things specific to Android XR. As you can see here, things like plane detection, persistent anchors, ray casting, face tracking are all done in that package in the middle. And finally, the XR Hands provides cross-platform hand tracking, the gesture detection, and the hand mesh support. It follows the OpenXR spec for joint layouts and hand construction, so your hands carry cleanly across those runtimes. So if you're using these high-level packages, you're set. Now we've covered OpenXR, let's think about the Unity APIs that extend on that. This is where those higher-level packages like AR Foundation come in. They sit on top of these OpenXR layers and provide a consistent way to access these features, like plane detection, occlusion, and anchors, even when they come from different vendor extensions within the OpenXR runtime. Unity will smooth out the differences between these so you can really focus on building those unique experiences. As I mentioned before, AR Foundation's been around for a while. We originally launched it back in 2018 to unify across AR Core and AR Kit. These are the AR experiences on Android and iOS phones. Then in 2024, we expanded it to include head-mounted displays, bringing AR and MR together under that common API. Again, what's important here is that this simplifies the work and the complexity that you need to do. And this is part of our long-term strategy in XR and beyond, is to provide you with consistent developer workflows that abstract away any of the platform-specific pieces. So when looking at those packages, use the highest level package that has the feature in that you need. So here are all the different features that you can have, and you can see here what the platform story looks like in our support through these packages. The chart shows you in the middle here visionOS, MetaQuest, and Android XR. And you can see that some of these things in orange are supported across all of them: device tracking, planes, anchors, and occlusion. And the value here is consistency. You write once, and AR Foundation takes care of those differences. So we've talked about how these packages make things easier. But there are still a few things you may need to account for when moving between runtimes. So let's look at some of those common challenges. So when talking about porting, there are still differences in each platform. There's differences in how each runtime handles certain system aspects. The first might be rendering and lighting. Each platform implements its own post-processing and tone mapping and rendering tweaks, so visuals can vary slightly from platform to platform and may need some tuning. Custom shaders might also behave differently across different graphics backends, especially if you're moving an older code base from GLES graphics up to the latest Vulkan API. On the mixed reality side, data sources can come from different OpenXR extensions or AR Foundation providers, which are underneath AR Foundation. So sometimes you'll need to adjust how the application's using those data. So test on different devices on these different platforms. And finally, input. While some things carry over, every runtime does have its own quirks, controller layout, tracking offsets, or gesture systems that might also need testing. It's also worth noting that Android XR is supported in Unity 6 forward. So if you're coming from an older version of Unity with your project, make sure to use the latest Unity XR packages and move forward to Unity 6 to get that full cross-platform support. So to wrap up my section, here are a few takeaways. Unity gives you that strong cross-platform baseline, so most of your foundation is already in place. Porting should be mostly frictionless, with just a few runtime-specific considerations around rendering and input. And Unity provides the tools and APIs to make that process as easy as possible. So with that, I'm going to hand over to Luke, who's going to walk through what this looks like in action.
Not ready for a demo yet, but at the end of this presentation, we will do a demo and we'll get there. So thank you very much for the introduction. My name is Luke. I work at Google on the developer relations team. It's kind of my job to listen to you guys. So I really want to hear your feedback, hear what you're thinking about the ecosystem or where we're going. And then I kind of feed it to Ryan, who's the product manager on the XR side. So kind of make sure your voice is heard and make sure our product teams can understand what sort of future we want and what sort of vision we're trying to build for Android XR. So Android XR is an extension of the Android ecosystem. It's expanding upon a very wide range of form factors to bringing the experiences to new dimensions. So when we look at Android Auto, Wear, all these other form factors, this is how Android XR sits itself in these form factors. We made sure to make it intuitive so you can bring your existing XR applications and Android apps into this new space. And we're leveraging existing Android technologies that you've already been using, so you can use it on the headset today. So this is such things as the Google Play services. A lot of things that you see on the Android ecosystem today is available on Android XR. So a few weeks ago, Samsung announced the first headset running Android XR on their Galaxy XR device. And I think this is a great future where we'll see a lot more devices supporting Android XR, from glasses to headsets. So we're going to see a wide range of form factors. But I think this is really where Android XR is getting involved, is it's going to be that platform that you guys can use. And then no matter what the form factor is, you'll have the same APIs and the same consistent experience as a developer. So Google's new XR platform is built on open standards like OpenXR and Vulkan. We have a long history of supporting open standards, and we're actively helping to push the XR industry forward through these standards, such as OpenXR, Vulkan, and WebXR. These standards provide the best compatibility for your existing applications and kind of ease that burden from bringing your existing applications over to Android XR. Whether you're porting an existing app or creating a new one, we want to make sure that Android XR is kind of that natural fit for your VR, XR, AR applications. One of the main goals, we want to make XR development as accessible as possible. So I think a lot of you have been developing for a long time in this space. So we really want to make sure that this new ecosystem, this new platform we're bringing is really easy for you guys to kind of come in and load up your applications. So over the next 15 minutes, we're going to go over some vendor extensions that are specific to Android XR. We're going to go through how you can implement AI into your applications using some of these Firebase SDKs we have as well. So again, all the rich ecosystem that we have on the Android platform are available on Android XR. So if we look at this long list, and it's starting to get longer each day, but because we're using the OpenXR specification, we have all the common vendor extensions there at the core. So a lot of the vendor extensions you're probably already using in your application are available. And then on top of that, Android XR is also contributing our own vendor extensions, just so that we can be enhancing and building new feature sets to the OpenXR community. So a few of these features are eye tracking. So this makes it possible to track the eye, orientation of the user's eye, helps with foveated rendering, so you always know where the user's looking. We have composition layer pass-through for mesh, so physical objects such as your keyboard, your mouse, you can kind of cut out a little area, and then from there you can have a pass-through within your kind of immersive application, so you can kind of see through. We have device anchor persistence, which makes it possible for you to save and store spatial anchors. So as Anthony was saying earlier, we're working a lot on the spatial entities. So we're looking at how we can anchor those into positions. We have face tracking, which basically provides detailed blend shapes of the user's current face. So if you think their mouth moving, their eyebrows moving, you can get all this information back and then put it into one of your own meshes and blend it in. So it really makes it really easy to have your own meshes and have your own models that you can blend in for face tracking. We have hand mesh, which provides a high fidelity mesh of the user's hands and is kind of that advanced alternative if you want a real representation of the user's hands rather than a pre-modeled, pre-rigged hand model. You can use this hand mesh and it'll give you an accurate representation of the user's hand. And then we also have scene meshing, which you can see on the right here, which kind of gives you the ability to look at all the mesh around you and from there build mesh for Unity. With this, we have Android XR's multimodal input system. So this gives you the freedom to design truly interactive experiences as you can interact with apps however you want, whether this be speaking, using their eyes, using controllers, and then you can also use some peripherals as keyboard and mouse. We do recommend you don't have to use a controller. We are a hands-first based device. So we have all the hand interaction profile hooked in. We have all the extensions available. So we do have a wide range of input that whatever experience you want to develop, you can make. But we definitely recommend doing a hands-first approach and then from there, adopting other inputs. On top of this, we have a wide range of performance settings that are already available. So I think a few of you that have already been developing might have already used foveated rendering, might have already used space warp. So a lot of these features we've made sure are available day one on the platform. So this really helps you get the most performance out of the device from day one. And then with that, because we have eye tracking, we can also do eye tracked foveated rendering as well. So you just get better performance out of the device. Along with this, keeping with Android security and privacy policies, some Android XR extensions do require runtime permissions. So when using OpenXR extensions, make sure to check out our developer website. And from there, we list what certain OpenXR APIs require certain permissions. So this will just help you get started quickly when you start using some of these APIs. Here's a nice quote of one of our partners, Trip. We actually have them on the demo booth, so you can go and see their experience. But we've been working closely with them over the last year to port their experience and many others. And we found that from day one, a lot of people have been having a lot of success and a lot of great experiences because we've decided to adopt these open standards such as OpenXR. So I think it's a great call out and something that we're quite proud of. On top of this, we kind of have two packages that we mainly recommend looking into when developing for Android XR. So earlier you heard Anthony talk about the Unity OpenXR Android XR package, this is the primary package developed by Unity and is the go-to recommended package. And then we also have the Android extensions for Unity. This is Google's XR package, and it's specifically designed for enhancing and using more advanced features that might be just available just for the Android XR platform itself. So you kind of have these two packages you can use. The Android XR extension package from Google is highly adaptable with the Unity extension package today. So we always recommend starting with the Unity package, and then from there you can see what other APIs we might be covering in our extensions package, just to allow for compatibility. So we definitely recommend checking out both of these packages, as it will give you a full list of all the APIs you can use today. So performance. So we know performance can be a big thing for your VR applications. We know we're trying to push high frame rate to these devices. So to help with this, we have quite several extensions in Android XR that will help you with the performance and make sure that you're delivering a great experience to users from day one. And you're probably going to hear this a lot in our talk, foveated rendering. It's a great feature. It really does help you get a lot more out of the device. We have Space Warp, which I think if you haven't already, definitely checking out Space Warp's a great tool, but it definitely depends on your use cases of where you might want to use this. And then on top of this, we also have a performance metrics setting built into Android XR. So if you go into developer settings, you scroll all the way down to the bottom, you'll see a new XR setting in there, and this will give you basically performance metrics at runtime on the device. So it'll tell you what the compositor is running at, where your GPU is, where your CPU is, and it's a great way to understand what's actually going on the device. So maybe you're not totally debugging at the moment, but you do want a live preview of what's going on the device. This is a great tool for knowing at runtime what performance is going on and how the GPU and CPU is behaving. Next, I'd like to talk a little bit about the Firebase AI Logic SDK. So this is the SDK that's used within Unity to use a lot of the Firebase implementations. So with this, it's an easy way to add AI into your XR applications. So the Firebase logic is the go-to solution for Android XR developers to leverage Gemini models within their apps. It offers production-ready features such as remote config. It allows you to update your models and your prompts without needing to release a new build. And it also has app check integration, so it can protect your Gemini API calls from abuse and everything else. The Firebase AI logic also includes an AI monitoring dashboard to help keep track of the API calls, the volumes, and associated costs with this. On top of this, there are two APIs you can mainly use within this SDK. So that is the Gemini Developer API, which is a great fit for people that are just starting, you're prototyping, exploring some of the possibilities you might want to use within Gemini within your application. So it's kind of like this frictionless way to get started and to start prototyping. And also has a pay-to-go plan, which is suitable for production costs as well. We also have the Vertex AI Gemini API, which remains the go-to for applications really within that enterprise space. So if you're looking for a production app, then Vertex API is kind of the go-to for more enterprise configurations. So we can have those two paths, and I think if you definitely want to start prototyping and using it, then the Gemini Developer API is a great way to go, as there are a lot of like free models that are there, so you can start prompting and start using. Here's a quick snippet of showing how you can use a multimodal prompt. So you can basically take an image in Unity, convert it, and then from there you can send it to Gemini, and from here it'll give a response on what it's seeing inside that image. So there could be certain use cases where maybe you're using pass-through, or maybe you're looking at a 3D object that you've generated. You can then pass this image to Gemini, and it can give you a response on that. So I think, a couple of lines of code, and you've got that working. So this is a great tool for really going that way. On top of this, you can also use the Gemini Live API, which allows developers to create kind of that real-time live communication, conversational experiences that you might be used to within Gemini today. So I think a lot of you might be interested in this if you're trying to create personas, NPCs, you're trying to create this real-world kind of live interaction with your NPCs and with things that are going on in your scene. So we definitely recommend the Gemini Live API, as it's kind of this stateful API that creates a WebSocket, and then from there you just get a live exchange between Gemini Live. So you have the ability to submit audio to it and get audio back, and then you can also submit text to it if you just want to do text-based prompting too. And then coming very soon, we'll hopefully be able to upload video, and you'll be able to get a constant socket back to be getting a response on what it's seeing through that video image. So if you want more information on the Firebase, there's comprehensive documentation. I know there's a lot of links there, but there's a lot of good documentation for supporting Unity within the Firebase SDK. So I definitely recommend checking out those, because there's so many different use cases. There's so many different things you can do within this package. So I think it's a great tool for everyone to start playing around with. And with that, I'm going to do a live demo. So I think for this live demo, we mainly want to show how easy it is to get started on Android XR. So for this example, I have basically the VR template that I think most of you might have seen already today. It's available on the Unity Hub. So it's just the standard package. I've done no modifications. I've just loaded it up. And then what we're going to do from here is we're going to go to our package manager. And then we are going to go to, I've already added up. But what you will do, remove it. And we will add it one more time. So if we do com.unity.xr.android.xr-OpenXR. And then if we install this package, this is all you should do, is just install the package once. And then if you come to the editor, and you just then make sure that you have two features enabled within Android XR. So that is the Android XR support and the Android XR AI session. And from here, we are going to do give it time to build. This obviously shows you guys it's all live, right? If it's all being built on my laptop right now. And then I don't see the screen, but. And then from there, you pretty much get all the tools that you're used to from XR Hands, the interaction toolkit, and everything kind of just works out the box as you'd expect it. And all you have to do is just include one package and enable two features. And yeah, everything just works. And I think a lot of this goes into what Anthony was talking about earlier, where you have that one layer that you're looking at. You have one API for the AI Foundations, XR Hands, and from here, that layer will then work on something like Android XR. So it makes it super simple for developing for this platform. And with that, And then with that, you should be ready to start publishing, right? It's going to be super easy to start moving your applications to Android XR. So the next thing you'll want to do is publish, right? So we have a great way, and we have a dedicated track on the Play Store for uploading your XR applications. So if you're just looking at creating immersive experiences and you don't want to upload to tablet, mobile, TV, we have a dedicated track for Android XR, and this gives you the ability to upload your APKs, test them, do everything you kind of normally have within your tablet and mobile experiences, but you have all this dedicated for the XR track now. On top of this, you have your test tracks, so you can do a lot of testing at production quality, so you can make sure that you have all the right people within your environment and making sure you get them the APK as easy as possible. And then on top of this, you can then release your application. You can release it in stages as well. So if you only want to start supporting certain areas or certain regions, then you can do that for your release track. And on top of this, you can also upload spatial content to this track. So if you want to start doing and showing trailers that are spatialized or 360-degree videos as a trailer within the Play Store, then you can do that. And you can make sure that people get to have that little experience of your application before installing it or maybe purchasing it. So I think it's definitely great that we can kind of give that ability to consumers. On top of this, we definitely recommend checking out our Android XR Unity samples. This has all the latest, greatest APIs that our team have been developing, and it kind of gives you a fun playground for demoing a lot of these APIs. So when you do get the headsets and you want to check out some of the APIs, you want to see samples of how they work, this is a great sample and like a showcase to you guys of, hey, this is how you implement some of these features. So we have everything from face tracking, we have gestures, there's a lot in there. It's growing every day, so we keep committing to it, and I think it's that great showcase for you guys to kind of play around and see what we have going on. And with that, I'd like to bring Demeo and Pedro on stage.
Thanks, Luke, for that great demo. Play to Device has been high up on our wish list. So let's look at the experience of bringing Demeo, our cross-platform cooperative adventure game, to Android XR. In this talk, I'll cover the challenges we faced, the solutions we deployed, and why we believe Android XR is an exciting new platform for developers in this space. Demeo is a cooperative adventure game for up to 4 players, recreating the magic and camaraderie of gathering around a tabletop and battle the forces of evil. We released Demeo in May 2021, so it's soon coming up on the 5-year anniversary. Launching, the game was on MetaQuest, Rift, and Steam, and initially it was only virtual reality. We have later expanded the game to be available on 12 different platforms, and today it's playable not only in VR, but in mixed reality and on traditional flat screen, with crossplay across all modes and platforms. Here's a behind-the-scene photo from recording the launch trailer of Demeo, and it's really hard to showcase XR games in a way that does the experience justice in many cases. But I think Demeo is one of those games that sort of make people intuitively understand why VR can be such a great medium. It has this connection to the tactile thing of playing a board game and something that people recognize. Having already brought Demeo to most commercially available platforms, we were really impressed in the team with the process of making the game run on Android XR. Just like Luke showed in his demo, you install the OpenXR Android package, you make some reconfigurations, and we had the game up and running surprisingly quick. However, on the Demeo team's part, we had lots of unresolved technical debt. We were using an older version of the Unity engine, we were using the built-in render pipeline and the GLE as backend. And for the game to reach its full potential on Android XR, we needed to address these issues and bring the game up to date. The first step in this process was updating Demeo to Unity 6, as it's required for the Android XR OpenXR plugin. Unity has done a great job with the migration process between major versions, and we were able to successfully transition to Unity 6 without any major hurdles. Then it was time for the Universal Render Pipeline, URP, in combination with Vulkan. It's recommended for Android XR applications to use these technologies since it enables eye-tracked foveation rendering, late latching, and a lot of other important features. We feel that these technologies are necessary to do the game justice on a new generation of high-resolution devices. The catch, URP is not backwards compatible with surface shaders and many of the custom shaders created for the game in the built-in pipeline. Demeo unfortunately had a lot of broken shaders, and only a few could be automatically updated. Also, the organization of assets in our game were such that it was hard to get a good overview of the extent of this migration problem. We needed a clear overview of this problem, and we said in the team, let's take this opportunity to implement addressables and rework the asset system. And this is a little tangent to the main topic of XR, but I wanted to show this because I'm really sort of satisfied with how this turned out. So we introduced an asset management layer that sits between the game logic and the assets. It enables async asset loading. When the game logic requests an asset, it receives a promise that can either contain the loaded asset or a unloaded callback for when the asset becomes available. And this architecture prevents the game logic from accessing unloaded assets directly. It can only work with instantiated game objects. And this diagram here shows the flow that we landed on. Assets remains unloaded until needed. They move through the asset cache and the management system before they reach the game logic. And this approach significantly reduced our memory footprint and reduced our load times. Also, at the time of doing this refactoring, we did not realize that it would later save us a lot of headache when deploying this game on Android XR via the Google Play Store. Because moving most of the game's assets to addressables made the base module of the game just small enough to meet the requirements of the Android app bundle that you need to use when you deploy on Google Play Store. With the new asset systems in place, we mapped out shaders actually used in the game and combined some of them into master shaders. This also happens to be really useful for the SRP batching in URP. Having few shaders is great in that system. We had run out of excuses to stall the shader migration any further. And many of our shaders were, as you can see, broken. This is the overview we got. And they had been created with node-based shader tools that resulted in code that wasn't easy to read or maintain. So instead of recreating these shaders manually, which would have been very time-consuming, we decided to explore the use of AI. So we had AI sort of translate a lot of these shaders into URP-compatible versions. And we were really happy with the results we got out of that. We felt that many of them were close enough to the look of the original shader, and it allowed us to sort of quickly move through this process and have something that wasn't just pink up and running. And then with that groundwork out of the way, we could bring in artistic input, sort of polish and tweak things and fix things that AI had missed. This was one of the first sort of real AI projects we had internally in the company, and I think this was like a use case that gave us a lot of value. Then let's talk a little bit about lighting. Demeo relies heavily on baked lighting. Light maps and light probes baked in the built-in render pipeline are compatible with URP, but they do not retain the same visuals. So looking through that, we felt that the lighting were on the verge of being shippable, but in the end we decided to redo the lighting for the game. It felt wrong to not utilize the new and improved lighting features in URP. Adaptive probe volumes is the replacement for the light probe group. APV automates and optimizes probe placement, and applies light data more efficiently. By switching to APV, we could move smaller meshes like level, clutter, decorations to light probes and free up space in the light map for the large objects. This gave us high quality lighting, and we're using less data. And this is just a quick view here on to the left, sort of the built-in lighting. Then when it was automatically ported to URP, you can see that the contrast and intensity is a lot less. You can tweak this a little bit, but it's hard to get back to original. And then the reworked lighting. The resolution is unfortunately quite bad here, but for example, on the vine here next to the tower, the lighting gradient is a lot better in URP when it's probe lit instead of light mapped. We were really happy with these results. Let's talk about the two features that allows the game to run and look fantastic on Android XR. So eye tracked foveated rendering really is a great technology. The human eye only notices maximum detail in a small region in the eye called the fovea. And then outside that, in the peripheral vision, the view is blurred. And foveated rendering uses this quirk and renders with high quality at the gaze location, and then can aggressively downsample outside. And this allows the game to both gain in resolution and frame rate at the same time. And the OpenXR implementation of eye tracked foveation works beautifully, and it takes Demeo really to the next level on these new devices. And here's a quick look at how you implement or sort of activate foveated rendering in the game. You need to select the SRP foveation API in the OpenXR settings. And this little bit of code you need to run at boot up. So it basically fetches the display subsystem and it sets the gaze allowed flag. And then you set the level you want. And for eye tracked foveation, I don't see any reason not to go with the highest level. If the eye tracking is configured correctly and calibrated, the player won't notice the really aggressive downsampling outside the narrow region of the gaze. And then for devices without eye tracking, we run with a little bit of fixed foveation. We feel that the sweet spot is at 0.3. It sort of gives a little bit of performance boost without making the game obviously downgraded visually. Opposite the foveation, late latching is an invisible technology that really makes VR and XR feel right. And I want to push on this because while it is being used, I think it's not used enough, and it should really be a default thing. And moving to Vulkan together with URP, you're allowed to use this technology or can use this technology. And what happens is that the frame generation and the game logic sort of splits off, and the frame is generated in parallel to the game logic. And the position of tracked objects, such as the camera, is inputted early in the frame generation, which makes the position stale when the picture is ready to, or the frame is ready to be drawn. And if the player is doing micro adjustments to the position or is in the middle of some quick big movement, that will really sort of be felt by the player. And late latching allows this position to be updated late in the frame generation and account for that change that has happened. And this is a look at the sort of the code for enabling late latching. It's very similar to eye tracked foveation. For foveation, you need to modify the XR display subsystem. And the little trick here that we have discovered, or not discovered, but that we feel is necessary, is that you can add a small epsilon to the position of the transform you want to late latch. And this makes sure that the late latching is happening consistently every frame. If we don't do this, we feel that late latching is dropping off and it's not being applied every frame. It's a bit weird, but that's how we make it work. Speaking of performance, after doing this rework of the game and making it run on Android XR, so Demeo is running on a wide variety of hardware, all the way from Quest 2 devices to PlayStation 5 and PlayStation VR 2, and desktops and so on. And for this update, we chose to go with a higher minimum requirement. And then hardware on the low end can maintain frame rate by dynamic resolution, fixed foveation, and preferably eye-tracked foveation, which really is the thing we're going for, because that sort of allows the game to really look like it's running on a PlayStation 5, despite running on a mobile device. And I would like to end this talk by saying that we have made continuous efforts in the code base to manage all the different XR platforms we're supporting. We have moved away from vendor-specific SDKs and refactored parts of the game to use platform-agnostic functionality and OpenXR functionality. And on Android XR, we are able to use our existing code base with very few modifications. And we sort of had a dream version of configuration of the game without any platform-specific setup or exceptions that we have used as a base for porting the game to different platforms. And this version transitioned Android XR almost seamlessly. And we feel like this will lead to a great reduction in frustration for developers working in this space. XR needs more standardization on software and hardware and what users can expect from their devices. Google and Unity are taking a leap in the right direction with Android XR. And we at Resolution Games are very excited to have a launch title on this platform. With that said, I want to invite Anthony back up to the stage.
Thank you.
Thanks.